Second question. A body is thrown vertically upwards with the speed of. Okay, see, so before I begin solving the next question, let us try to face one of the problems most of us have usually, you know, what we feel while solving a specific numerical in the question paper during the test or while you practice your daily practice problems. Uh, Basic problem is that we get stuck while thinking of which formula to apply. And then there are so many cases within us say for example vertical motion itself, there can be many combinations of cases, and then you are always stuck uh, which question should be solved by using which particular equation. So my suggestion to this is, while we practice this set of videos, right, the set of questions given in the form of videos, I have designed the curriculum in such a way that if you practice, if you do just practice along with me these questions, and you will reach a particular situation, you'll reach a particular level, I would say, uh, wherein you'll be able to understand, and it comes it the formulas will come naturally to you. Okay, having said so, let's start the question. It goes like this. A body is thrown vertically upwards with a speed of 20 meter per second. It will return to the thrower's hand. It's not throws, it's throwers. Apologies. The point that I was trying to convey earlier is, if you ask me what is formula for the time by which the ball comes down, there are standard formulas for that. But I never suggest opting these kind of formulas. It will hardly take a second to draw the, a second or maybe a couple of seconds to draw the diagram and then try to interpret the question on your own. But yes, we don't have that much time during your final examination. Let it be any examination you write. So, one primary component of solving, getting good marks in the objective exam is speed. It doesn't mean you have to solve the questions quickly. It means that speed, you should be able to solve the questions in a quicker way, and that speed should come to you naturally. Okay, right. So, as usual, let's start the question by start solving the question by drawing a rough diagram. Body is thrown vertically upwards, so the body is projected from here. Let this position be A. The velocity at A is basically 20 meter per second. It will move like this, it will reach the maximum height, be momentarily at rest, and then it will come to the same person, right? So the person will catch it over here. How many seconds will it stay here? So one thing that we need to understand here is time of ascent is equal to time of descent. If you ask me how, there's a proof for this, but that's not the point of discussion now. So if it's A to B, and then from A to C, we can say that time to travel AB is equal to time to travel BC. Okay, so this is one concept that we should be thorough with. Okay, now coming to solving the question, it's very simple. It's really simple. See, consider the motion along the line AB. Along the line AB. What is displacement velocity time relation? V is equal to U plus AT. We know that V is velocity of the position at B, U is velocity of the body at position A is minus G, into T is time along AB. Now, again, you may have a doubt in taking the convention of time, the convention for velocity and acceleration. See, it's simple. I'll explain it in every video. So we go like this. The body is projected upwards, right? So we have velocity in the upward direction. Acceleration is acting in the opposite direction. So it would be negative g. Now you may ask me, sir, we always project the body upwards. Then why do we need a negative velocity? We'll come to that, right? So be patient while you learn how to solve the questions. The point here is to understand the methodology of solving. Okay, so VB is, we know that at point B it is momentarily at rest, so VB is going to be equal to 0. UA is given as 20 meter per second plus minus G is, let us take it as minus 10. Then we have TAB. Now, if you transpose minus 10 to the LHS, what do you get? Plus time taken for AB into 10 is equal to 10, 20. Therefore, time taken to cover AB is equal to 20 by 10, which is 2 seconds. Now, is the question asking the time taken to reach AB? No, the time taken is being asked to come back to the same hands, which means we have to take the total time. And since time of ascent is equal to time of descent, I would say the total time would be equal to 2 times the time of ascent, right? 2 times time of ascent, which means this would be equal to 2 into time traveled for AB, which is 2 into 2 seconds, and therefore the answer here becomes 4 seconds. 4 seconds.